on the homework number 5, question number 1. So number 1, using the integration by parts. Well, the whole chapter, homework 5 is about integrating by parts. By parts. And tomorrow, not tomorrow, on Friday, I'm going to do the recap, kind of the summary of this section. So number 1 is about integrating from 0 to 2, x squared e to the negative 3x, and with respect to x. So for the by parts technique, you're gonna have in the form that the integral of the u times dv equals u times v minus integral v du as a formula which derived from the product rule. I'm gonna use different color. So in Calc 1, right, the u times v or the f times g or the product of the two functions, you can derive the formula by doing the multiplication of original and the derivative of the other, and then do the other way around. And then on top of Calc 1, when you do the integration and the derivative, they cancel each other out, become uv, and this become integral u. And v prime this is going to be dv, and then plus integral. I should not put the v prime there. And then this is going to be v du, and rearrange the term, integral u dv equals u times v minus integral v du. So that's kind of a quick reference for the formula, the by parts formula. So when you see the product of the two functions and the u sub technique cannot be used, so you have to think about what function that easier to find the derivative and what function is easier to find antiderivative. So you have to set up your brain in two modes at the same time. Think about one easy for the forward way, the other one for the backward ways. So the tip for one of the tips of the doing the by part is you're gonna identify the function type. If you already check out the notes, Natalie, is LEAD. Did you recall this acronym, the LEAD?
Yeah, I did.
So from the integrand that you have x squared and e to the power negative 3x. So you identify its function type. Therefore, x squared, that is the algebraic function. Okay, so x squared gonna fall into the category of the algebraic function. Polynomial is one of the algebraic function. And the e is very obvious, is the exponential. Okay, and when you identify in order like this, the upper one, the one on the top of the rank here, you let it be the u function, and then the rest of them gonna be dv. And when you see d, that means differential v. You have to bring the dx together with the expression. So from the beginning part here, the formula of the by parts, you're gonna need to multiply the u and the v. You already have u, but you don't have v. You're gonna have to find v by finding the antiderivative of this. So v is the antiderivative of e to the negative 3x with respect to x. Okay, and using the u sub technique, you're gonna get e to the negative 3x divided by negative 3 for the v. Okay, get v, you're gonna need the v which already found. And what is the differential u? What you have to do from the u that we identify at beginning here. So du, or the differential u, is the derivative, which is 2x multiplied by dx. We get 4 pieces we need. So I'm gonna write as a summary of the prep work. So now we have u as x squared. So du is 2x dx. The dv is e to the negative 3x dx. The v is negative e to the negative 3x over 3. You need 4 pieces here and then bring it into the formula. From the bypass formula is u multiplied by v minus integral v du and the same lower upper limit. The u is x squared. The v is negative e to the negative 3x over 3 subtracted by integral v negative e to the negative 3x over 3. The du is 2x dx. As you see, you cannot miss the differential portion of the expression because you're going to have to put them together to form the integration. If you miss this part, you're going to lose a half point. Okay, so are you okay so far, Natalie, until this point?
Yes.
Okay, so then from this one, let me ask you, where were you at when you work on the problem?
Hold on, give me a second.
Okay.
I think it was with the limit half that I got stuck with.
Do you mean when you evaluate using the lower limit, upper limit?
No, I think it was like I was able to do like when I was multiplying it out, getting the antiderivative of the negative e over 3 to the negative 3x times 2x dx.
Okay, so you are at that step or you can go further than that?
That's where I was.
Okay, so actually this is just halfway done and we're gonna have to apply another bypass technique. Okay, let's clean up a little bit. So the coefficient of the first term is negative 1 over 3 x squared e to the negative 3x. And then for the second group, clean up as much as you can and then work on the core piece of the integration. Negative becomes positive. 2 and 3 becomes 2/3 as a coefficient. And then integral from 0 to 2 e to the negative 3x multiplied by x with respect to x. You still have to use another round of bypass. And for this step, same way that you analyze using Lie. So this gonna be the u and the e to the negative 3x gonna be dv, and then keep going again with the 2/3 as a coefficient of this bypass process. Okay, so gonna be more. All right, so this is one of the ways to do the first problem, and I call this is the traditional way. Another way, if you already check out the notes, I'm going to repeat the problem. Okay, number 1, integral from 0 to 2, x squared e to the negative 3x dx. For the bypass, you always identify the type of the function. And we know that x squared is algebraic and the exponential is e to the negative 3x. And the special case of this one is x squared is the polynomial function. If it is polynomial function, you can use the tabular bypass. Tabular. What does it mean to use tabular bypass? You draw the table, one column, you're going to find the derivative all the way until you get 0. The other column, you find the antiderivative, okay, until the last row that you have the derivative 0. So the hint is, since we know that the x squared is a polynomial, you're gonna have to keep going finding the derivative, until you get 0. So that means for this case, you're gonna have like 4 rows, okay? And then After you set up the derivative until you get 0, that's kind of tell you how many antiderivative you're gonna have to find. The right column gonna be this is the u, okay, and the right column is gonna be the original dv. And then you keep going finding the antiderivative every single round to get negative e to the negative 3x divided by 3. And another round gonna have positive side this time, e to the negative 3x over 9. And one more round because we have to complete the whole table, and it completed at the row that the derivative 0. So the last one, the antiderivative gonna be negative e to the negative 3x over 27. Okay. After you complete the table or the tabular bypass, how do you use the tabular bypass? You're gonna do the multiplication from the left row to the lower right row in the next column. Like I use the bar here to represent, like you're gonna multiply x squared and negative e to the negative 3x over 3, multiply 2x and e to the negative 3x over 9, 2 and negative e to the negative 3x over 27. And how do you put them together? The first product, you're gonna put the plus sign in the front of the product, put negative sign in the front of the product, put the plus sign in the front of the product. So the sign will alternate every time, but starting from the plus sign. And how do you put them together? By using the tabular bypass. The first product is x squared multiplied by negative e to the negative 3x over 3. And the second one, put a negative sign in the front of the product, which is the product of the 2x and e to the negative 3x over 9. The next product, put a plus sign in the front, the product of the 2 and negative e to the negative 3x over 27. And this is a definite integral. You're going to put the bar in the back, represent x equals 0 as a lower limit, x equals 2 as the upper limit. You are done in one line. If you went back to, let me go back to the traditional way. For this traditional way, you're gonna have to do 3 rounds of bypass to get to the answer. Okay, nothing wrong if you want to do the traditional bypass, but for this special case, the easy function, the one that easy to find the derivative, it happens to be the polynomial. When you find the derivative, it's going to end up with a 0 eventually. So that's why the tabular bypass is very convenient and is handy to use when you have to deal with this type of the bypass problem. Okay, so after that, you just simplify and replace the value with the negative, with the positive 2, and subtract it by replacing the value with a 0, and get the answer out as the final answer.